Ever looked at someone's code and be like, what's this guy trying to do here? Today, we're going to explore how patterns can help you make code that is easier to communicate about, easier to understand, and easier to maintain. So, what are patterns? All right, in the 1990s, the concept of patterns started showing up in software development. It's the practice of identifying solutions to common problems that are repetitive and naming them so that you can reproduce them in different projects. And then four guys came out with a book called Design Patterns that is highly influential, especially in object-oriented software development. All right, so the Design Patterns book is a book of 24 design patterns that I highly recommend that you read. And it sort of popularized the term of using patterns as a template of problem solving that you can share between colleagues and other coworkers to sort of align how you think about problem solving and also work in object-oriented software. So patterns are great. And knowing a lot of patterns will in fact make you a better software developer. It helps you write better code, easier to maintain. And if you can communicate it and identify the different patterns, you can also make them explicit so that people can find documentation and explanation of the problem on the problem solving approach that you're taking in this specific case of software that you're building. However, a word of warning, and I've seen this happen a lot of times, patterns can easily be overused. So, especially in one team that we had of Remotics, we had this guy who came in and we gave him a patterns book and he started reading and he read through it. And for months afterwards, every code that he made had as many patterns as possible in the solution that he made. And this is great. He had a great learning experience. But if you've seen my video about hobby projects, I would recommend that you keep the exploration and learning new patterns in the hobby projects. Because whilst having some patterns repetitively in a software architecture makes your code base easier to understand and easier to teach and communicate about, having a wide variety of patterns increases the cognitive load that your developers in that code base needs to know. So be mindful of what patterns you introduce and introduce them deliberately. And I realize what I'm saying now requires some experience, but looking from previous code bases that you've been working on, if you look at them and what patterns they've applied and when they applied them, you can always gain this experience as you move along without having to apply patterns in production code. Don't get me wrong. This is not the worst scenarios you can have in software development where someone applied too many patterns, but it does make the code more cumbersome because the more patterns you have in your code base, the longer it will take to onboard new developers. And the more the new developers need to know, understand, and read up on to understand the different problems. A good architecture will select a small set of patterns that it will repeat over and over again in a strategic and well thought out way. That way, you need to teach new developers maybe 5 or 6 patterns, and they can specialize on those and become really efficient in using them. And then you can see the patterns fall out through the code base and be repetitively at high quality instead of having pattern implementations of low quality throughout your entire code base. So this said, this is the approach that we try to use in the Quanti platform. We have certain patterns that we apply over and over again to make sure that the code base behaves similarly across the different parts of the code, and to make sure that developers can recognize, oh, we're working in this type of setup, we're working in this type of pattern, we know how to do this. Unfortunately, I know that I haven't been as explicit with what patterns we're using, and especially for new hires coming in, it's hard to know the patterns unless someone explicitly says, oh, we're using this pattern. So in this video, I would like to go through 2 patterns that we use extensively in our action calls and how we call our APIs. All right, let's start with the parameter object pattern. People can argue that this is in fact not a pattern, it's a way of writing code and it's a preference, whatever. And I will, in this video, call it a pattern, and you'll hopefully soon see why. So say we have this function called calculate travel cost. And it takes a bunch of parameters, it needs to calculate a travel cost. However, if we use the normal function inputs, we sometimes end up with a scenario where we have to send in nulls, undefined, -1, weird values. And these are all code smells. It makes the code really hard to read. There are different solutions to this. I mean, magic strings, magic numbers, these are code smells that you can solve by introducing constants. But another approach that you can take is to introduce a parameter object. So while the function is not the best named, and while it's hard to read the parameter structure of the first function, having this parameter object explicitly tells you the name of the parameters when you're calling the action, which means that if I look at this action call with this new structure, I can see that the parameters are named at the place of calling, making that part of the code easier to read and understand. I can now understand that, oh, these parameters mean something. I know what I need to send in here. And depending on what language you're using, you can have type safety or static typing, or even compile, like if you're in a compiled language, it can check things for you. And you can even combine this with, for example, the builder pattern to create really well thought out and easy to read and maintain APIs. So the idea here is that we want to create an API that we're working with where we can clearly always read what the intention of our call is at the place of calling, because that's where we want to create the change that we're actually working for. So a specialization of this pattern is the query specification pattern. Again, specialization, Basically what this says, if we want to fetch an object, we will send an example of the object that we want to have to our find function. So we can use this as a really good way to create filters, for example. It works really well with a repository pattern. And you can see this being used a lot in modern ORMs or in different APIs where you access data. But basically what we're doing is, say for example that I'm querying for orders and I want to find all the orders that have been delivered for a certain customer number. Then I can create a specification of what such an order would look like, send that to my find function, and then my function will return the results of the orders that match this specific query. This allows me to have a very concise API for my finding function or list function, and I can still, in the back-end part of it, create a highly effective query depending on what the inputs are to my list or find function. So I tend to think of the query specification sort of like a template or something that you compare the other object with. Then I usually, for a quick and dirty implementation, I take the original object and I tell it that you can have all the different fields available on this object to query, but I don't need to send all of them in. So the validation for a query object is different than the validation for an entity in a domain-driven architecture. So you can and it's all about how you validate that input. They're very similar, but it's how you validate it. We can make the querying of these orders even more powerful by introducing simple query functions that we have when we search in databases, such as greater than, equals, included in list. And this allows us to create really powerful filtering functions in our API. So a well-designed query specification pattern is also serializable. So we can send this object over a wire and serialize it on the other end, making it a very good pattern for API development. And knowing this, let's take a quick look at how we utilize the query specification pattern in some normal ways, but also in some quirky ways in the Conte platform. So I already mentioned that our list endpoints in the Quanti platform uses the query specification pattern to allow you to filter out what information that you need to have. However, about a decade ago, I was working on another system that was also heavily integrated to different ERP systems. And what we kept doing as a regular basis in that was that we had the integration in its own database. So it had its own state. And specifically what we kept there was the identity of, for example, an order in the ERP system, and then we had what that identity was in our system. So basically it was a key value pair of like, oh, it's called this in this system and this in that system, that we can then use to translate the IDs between the two systems. However, this became quite a problem if this database ever got out of sync, got lost, destroyed. It was a whole mess to take care of because you have state in two different places. So when we designed the Quanti platform, we introduced a concept called metadata. All entities in our platform have this concept of metadata. And the idea is that Quanti itself knows what the identity is in the integrated system. So you can, and this helps debugging, it helps querying for that. We'll get to that in a moment. But it keeps all state in one place, and it keeps it in a place that is also backed up and maintained on a regular basis. It's not a database on the side, it's not someone's homebrew project or whatever. It's together with your business data. So let's look at a quick example of where we use metadata in our Quanti platform. This update function updates an order with an external ID. In this case, it's a Salesforce ID for a Salesforce integration. And now that we've updated our order, we can use the metadata on the order to find that order again using the external system's ID. And this is important because it saves us a lot of time and effort. Because if you don't have that, you need to either go look in that key value lookup table for the ID, or you need to ask the system. There's a lot of back and forth. And we'll try to eliminate as much back and forth in our integrations as possible because that makes them more efficient, more reliable. Not only that, we can also look at the order in our system and see what systems have integrated with this order, because the metadata object has some quirks to it as well. For example, you can't overwrite another key. You need to explicitly know what key you want to set the metadata for. You'll never be able to overwrite something by accident. This is because we use the metadata as an integration point. So when I look at an order, I can immediately see, oh, this one has been handled by our logistics partner. I can see that it's been shipped to the ERP system. I can see that it's gotten invoice ID because it's been sent to an invoice handling system, etc., etc. Just by looking at the entity itself, I already know a little bit of what this entity has been manipulated by and what integrations are at work for this particular order. All right, I mentioned back and forth and how we try to eliminate that. There's one other interesting thing that we have on our actions, and that is the target parameter. The target parameter allows you to send an action and say, I want to, for example, update the order that corresponds with this Salesforce ID. And you do that by specifying in the target, it has a metadata with the Salesforce ID and this. This means that the integration does not need to have this key value pair lookup table. It can instead just, I got a message from Salesforce, it has this ID, there is an update of this order with this ID, update the order corresponding to this one. And combining this with an upsert means that we can make sure that we have unique values on the identities, because if it finds something that matches, then it will update it and upsert will create if they don't. This means that there will only be one order matching this Salesforce ID in our system. But more importantly, it means that the integration becomes more of a mapping between the two different domains of the ERP system and our system. So we just need to figure out what business events we're being signaled for, how the different fields correspond to our states and fields on our end, change that to an action call, and then put it on a queue so that our system can work through the data pipeline and get the correct data. Having this set up with the target and the metadata capabilities of our actions and entities means that our integrations can work without having to look anything up. They just become mappers between the data structures on the integrating system and our system. So we translate the different fields. Naturally, of course, if there's data missing or we need to look something up, then it needs to go a call. But if it's a one-to-one, it's just a map or transform to our data structure, and then our system can just consume that from a queue, and then like working through the integration process without having us to go back and forth with each and every update. Oh, I need to find the order that corresponds to this ID, and then I need to check what's changed, and then I need to send that to our system. The Quanti platform takes care of all of that when you're integrating, if you write your integration correctly. And that's why these two patterns are so important that you know and understand that we have these capabilities in their platform, making us so much easier to integrate with, or making it so much easier for us to create integrations for other ERP systems. All right, so I'm Morten Nielsen. I'm a serial startup CTO with over 2 decades of experience. I focus primarily on building software products, companies, and teams, and being as frugal and efficient as possible with them. And part of that is making sure that my teams also has the knowledge and the teamwork skills in order to perform at a high level and deliver our software product in the best capable way. So this is what I make videos about, because I share these with my team, and you're welcome to listen in and join in on the conversation as well. Please like, subscribe, leave a comment if you like it. And otherwise, I'm going to finish off by saying that knowing a bunch of different patterns helps us build scalable solutions. And I mean scalable not from a performance perspective here, but from a teamwork perspective. Having a set of patterns that your team specializes in because they are the patterns that you're using in your software architecture, having those explicitly explained and communicated and documented will help your onboarding process. It will help your team communicate better and help your team write better code, or write higher quality code together as one team. All right. Thank you so much for listening. See you next time.